Hi class, welcome to Research Methods. This is our walkthrough video for basic tests, and it is kind of long, so please take breaks. Make sure, get some water, get a snack. Feel free to pause and take as many breaks as you need. To get started, what I have open is the Canvas page for our assignment, and I have the PowerPoint. I have the lab sheet for basic tests, and we'll open up JASP with the JASP data set called Data Analysis. The basic tests we'll be running are a correlation test, an independent samples t-test, and a paired samples t-test. Let's start with a correlation. What is a correlation? Evaluating the relationship between two variables. We use the Pearson's correlation coefficient to give us the magnitude and direction of that relationship, and we use an effect size called the coefficient of determination to determine how much shared variance is between those two variables. So let's try it out. Let's say our research methods instructor thinks that there may be a relationship between conscientiousness and perceptions of research methods. Specifically, he thinks that those with higher conscientiousness scores will also have higher perceptions of research methods topics. So, what variables are involved here? Well, conscientiousness and perceptions of research methods. What is the null hypothesis? That's going to be the one that says there's nothing. There's no relationship between those two. What is the alternative hypothesis? Well, our research methods instructor thinks that as one is high, the other one is also high, and that is a positive correlation. In other words, a directional hypothesis. He's saying that the relationship between X and Y is going to be greater than 0. Let's go over to our lab sheet and get started there. On the lab sheet, it starts with the purpose, the materials, and the overview. On the second page is where we start the correlation test. We'll move over to JASP and open up the data set. Notice that JASP is saying I need to update to the latest version. I'm not going to do it right now because I don't want to interrupt the video, but it's fine to update JASP to the latest version whenever you see that. For me, I'm going to go over to where I've saved the data file in my datasets folder. Data Analysis JASP and open. As usual, JASP will open in the data frame, right, where we can see all of the variables and what type of variable they're classed as, nominal, ordinal, or scale. What we want to select is regression classical correlation. So regression classical correlation. And here we're going to need the two variables that are part of the hypothesis: conscientiousness and perceptions of research methods at time 2. What alternative hypothesis are we testing here? Remember, we said it's a directional hypothesis that we think that these two are going to be correlated positively, right? So we need to let JASP know that. Alternative, correlated positive. We also want to check the box for confidence interval. It's going to be right here in the additional options, confidence intervals. So let's take a look at the results now. The correlation coefficient is -246. Definitely not a positive correlation, right? The p-value is 0.983, not less than 0.05. And the range of the Pearson's R, so the confidence interval, is from -0.42 to 1. So Notice that the confidence interval includes 0 when you go from a negative number to a positive number, which is consistent with finding that the p-value is not significant. So this is not a significant test, and the correlation is negative 0.246. Let's see what other information we need. We also need the mean and standard deviation for both of those variables, for conscientiousness and perceptions of research methods. And we need the effect size. We don't have that yet. Let's go back and take a look. To get the descriptives for these two, for conscientiousness and perceptions of research methods, we're going to need to get a new descriptives panel, just like we did before with sample descript, and put conscientiousness and perceptions of research methods over there so that we get the mean and standard deviation for both of those. But we still need the effect size. Recall that effect size, when we're doing a correlation test, is that coefficient of determination, which is just the correlation coefficient squared. So all we have to do is take that number, negative 246, and square it, and that will be our effect size for this test. Let's take a look at an example write-up. So, a correlation test was conducted to examine the relationship between variable 1 and variable 2. So you would need to fill in those two with what they were, and the mean and standard deviation for each of them. State the alternative hypothesis and if it's directional or non-directional. Indicate if your results were positive, negative, weak, moderate, strong, significant or not, and provide the stats line. The stats line is the correlation coefficient, the p-value, the effect size, and the confidence interval. And then also give an interpretive statement. So you would have to fill in the missing information, and feel free to move this around. What you want to look at is making sure you have all the information in there. What test was conducted, with what variables, what were the results, the stats line, and your interpretive statement. Before we move on to the next test, let's take a look at real quick at how do you visualize this test. Again, to visualize a correlation, you use a scatter plot. So we need a scatter plot between conscientiousness and perceptions of research methods at time 2. It turns out that this is really easy. All we have to do is go put a check mark on the plots, scatter plots, in the input area that's already there in JASP. Let's take a look at that. In the correlation, I can go down to plots and do scatter plots. Let's take a look at it. So there's the scatter plot, but notice how it's got all this white space? It's not quite as pretty as the one we did for the correlations before. Let's take a look at, I'm going to fold this one back and come back down to descriptives input panel where we had just the descriptives of conscientiousness and perceptions of research methods. And let's go down to this plot, looking for scatter plot. And I'll turn off the graph above and the graph to the right, and I'll remove the regression line. Let's see that. So that's kind of nice. We have conscientiousness on the x-axis and perceptions of research methods on the y-axis. So you would save either of these. This is a scatter plot, and this is also a scatter plot. Either one of them is fine. Going back to our PowerPoint and the next test. So to conduct the t-test of independent samples is a test we use when we want to look at two independent groups. Is the average of a score different between those two groups? A significant test would say that the differences between those two independent groups is more than just by chance. And we look at the average of each group to tell which one is higher. So let's try this out. Our research methods instructor thinks that students who have plans towards graduate school are going to have higher perceptions of research methods compared to students who plan to acquire an applied job after graduation. So, what variables are we talking about here? Well, the outcome variable, the dependent variable, is perceptions of research methods. But the input variable is students who plan to go to graduate school or plan to go to a job. That's one variable with two conditions. So our null hypothesis is that there's no difference between those two groups. Nothing, no difference. The alternative hypothesis, according to our research methods instructor, he thinks that those planning to go to grad school are going to have a higher perception of research methods than those planning to get a job, to go applied. This would be a directional hypothesis. Let's check it out on our lab sheet. So we need to start a t-test input panel, classical independent samples, with these conditions. We'll go back to our input panel, t-test, independent samples. Now we want the dependent variable, perceptions of research methods, there. In the grouping variable is where we want that plans after graduation variable, that grouping variable. Which group are they in? And in our data set, it is called yes, no, one. Now, I know that because I'm familiar with the data, but let's take a look at the data sheet again, the data panel, and go over to yes, no, one. There it is. So those who indicated they plan to go applied and those who indicated they plan to go to graduate school. If I click on the name of the variable, I can see that group 1 is the applied job group and group 2 is the grad school group, right? And we'll need to know that to set the alternative hypothesis. Here in our input panel, let's go down to alternative hypothesis section. The research methods instructor hypothesized that the group 2, the grad school group, would be higher than group 1, the applied job group. So we need to indicate that in alternative hypothesis. What else do we need? We want to ask for the effect size. That's going to be here in additional statistics, effect size. It already defaults to Cohen's d, so we're fine there. Let's take a look at these results. The t-test estimate is negative 1.587. Degrees of freedom 73, p-value 0.058, and Cohen's d of negative 374. Notice that for a test to be significant, the p-value has to be less than 0.05. That means that this test is not significant. The p-value is not less than 0.05 by a little bit. What else do we need to report this test? We need the mean and standard deviation of perceptions of research methods for each of those groups. Let's see what we can find out in JASP. If we go over here to our input panel for independent samples t-test, we can ask it for descriptives. And now in our results, we have the mean and standard deviation for the applied job group and the mean and standard deviation for the grad school group. So here we can see that the grad school group did have a higher average perceptions of research methods compared to the applied job group. However, that difference was not significant. What else do we need here? We need a visual ability to see what's going on with this test in these conditions. So we can get a box plot by going over to we're going to need to get a new panel. We'll get descriptives, and we will get perceptions of research methods, and we'll split it by the yes, no, by plans after graduation. And then we can come down to plots and ask for box plots. Let's see what we get there. There we go. Our outcome, perceptions of research methods, the average for applied job, and the average for the grad school group. So we can save this image for the write-up and be able to tell your reader that you have a figure to help illustrate that. Wanted to show you one other neat trick. We go back up to our independent samples. And if we put descriptive plots here, it's not a box plot. It's kind of like a line graph. So the average for grad school, the average for applied job, and the line between them. So that's kind of a cool plot as well. Let's look at the write-up for this. So you can use this if you want. You don't have to. You need to make sure everything in your write-up has the information it needs. The test that was conducted, the variables involved, and the results, stats line, and your interpretive statement. But if you want to use this, you can. You would need to fill in the parts that are missing and make sure it makes sense. You have the groups, the mean and standard deviations for each group, the outcome variable, state what the alternative hypothesis was and if it was directional or non-directional, indicate the results, including the t-test estimate, the degrees of freedom, the p-value, and the Cohen's d effect size, and then also your interpretive statement. One more. Let's look at the dependent samples t-test. And again, the difference between an independent samples t-test and a dependent or paired samples t-test is that here in independent, the groups are totally separate from each other. The participant is only in one of those groups. Whereas in the dependent or paired, it can often be that the participant takes the test or is measured twice. They're measured at the beginning and at the end. So like a weight loss program or a pre-test, post-test kind of assessment, that is when you would use the paired t-test. A significant test indicates that the differences between the two scores, the pre-test and the post-test, did not just occur by chance, that they are significantly different. And you can look at the average, the mean of each of those to find out which one was higher, the pre-test or the post-test. So we'll try it out. Our research methods instructor thinks that students in his classes will have a higher perception of research methods at the end of the term compared to the beginning of the term. What variables are involved here? Well, time 1, perceptions of research methods, and time 2, perceptions of research methods. And the null hypothesis is saying there's no difference between those two scores, that time 1 is no different than time 2. Whereas the alternative hypothesis, the research methods instructor, feels that the time 2 score is going to be higher than the time 1 score. So that is a directional hypothesis. Let's check it out on the lab sheet. So we want t-test paired samples with time 1 and time 2 in the variables box. Classical paired samples. We want time 1 and time 2. Here we go. What is our alternative hypothesis? Well, our research methods instructor believes that time 2 is going to be greater. So in the alternative box, we want this one. Measure 2 will be greater than measure 1. We also want to ask for the effect size of the test. Okay, let's see what we have here. Our t-test indicates that the t-test estimate is 2.321, degrees of freedom 74, and the p-value of 0.988, and a Cohen's d of 0.268. We see that it is not a significant test because the p-value is not less than 0.05. What else do we need here? We need the mean and standard deviation for time 1 and time 2. And what else do we need? A box plot, right? So let's work on those. When we come over to our input panel, we can ask for descriptives, which gives us the information about the mean and standard deviation for time 1 and time 2. Now notice that time 1 had a 3.97, whereas time 2 had a 3.76. That means that the participants had a higher regard for research methods topics at the beginning of the term than they had at the end of the term. Not good news for the research methods instructor. He might want to look into that. What else do we need? The box plot. We can try descriptive plots. I think that's going to be the line graph again. Yep. So time 1 compared to time 2. But let's see what we need to do to get the box plots. Probably descriptives. We'll get time 1, time 2. Scroll down to plots and ask for box plots. There they are. So I can save those and include them in the write-up as well. Either graphic is fine. You need to include a graphic for each test. Let's look at the example write-up for this. So, a paired samples t-test was conducted to assess students' perceptions of research methods at the beginning of the term, include the mean and standard dev, compared to their perceptions at the end of the term. The directional hypothesis stated that perceptions would be significantly higher at the end of the term. What did the results find? You're going to include if they were significant or not, and the t stats line. So the degrees of freedom, the estimate of the t-test, the p-value, and the Cohen's d, and your interpretive statement. So now let's check out the assignment. I'll go back to the lab sheet because we have what you need to turn in for the assignment is a separate paragraph for each test. In each paragraph, you need all the information to report data analysis. You also include a figure for each test. APA, you're going to have a student title page on this one. Your full title is Basic Test Results, and then also some headings. You need to watch your italics. And because you have figures, you want to have a figure number, a figure title, and you're going to let your reader know in the paragraph that there's a figure associated. Usually you put something like, see figure 1 for an example, or see figure 1 for the scatter plot, things like that. You let your reader know in the narrative that there's a figure in the appendix. And you can see APA Section 7 for lots of guidance and examples on how to do these. Let's go to the assignment itself. It's got the materials, how to complete the assignment, the APA expectations, and your write-up, and the exported results from JASP. And you also have your rubric here. So that is it for this walkthrough. Thank you for sticking through it, and I look forward to seeing your write-ups.